Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about the empirical rule. All right, so the empirical rule is also known as the 68, 95, 99.7 rule. It states that 68% of the data lies within one standard deviation of the mean, so plus or minus one standard deviation from the mean. 95% of the data lies within two standard deviations of the mean. And 99.7% of the data lies within three standard deviations of the mean. All right, so here is our normal curve, and it has the mean down the center. So this is we're going to go three standard deviations out to the right, three standard deviations out to the left. So this is the mean plus one standard deviation, plus two standard deviations, and plus three standard deviations. And then the mean minus one standard deviation, minus two standard deviations, and minus three standard deviations. All right, we would write this as capital N, and then your mean, comma, your standard deviation. Typically, those will be numbers, not just symbols. All right, and then 68% of the data is within one standard deviation, 95 is within two standard deviations, and 99.7 is within three standard deviations. All right, now we're going to look at that same curve, but we're going to break it down further. So again, we said 68% was within one standard deviation. So half of that is 34%. And then 95% minus the 68% divided by 2 gives us the other 13.5% on the other halves. 99.7 minus 95 divided by 2 gives us the next 2.35%. And that leaves us with 0.15% on either ends. Okay. All right, solving using the empirical rule. The empirical rule gives us approximations, which are great to use when estimating area under a normal curve. However, we will learn methods to be more precise using our calculators in the future. The weights of adorable fluffy kittens are normally distributed with a mean of 3.6 pounds and a standard deviation of 0.4 pounds. Answer the following questions using the empirical rule. So I'm going to kind of draw out this model. It's a normal model with a mean of 3.6 and a standard deviation of 0.4. So I have 3.6, and then I'm going to go over. I'm going to count 0.4, 0.4, 0.4, adding that each time to the right, subtracting 0.4 each time to the left. All right. The first question, what percent of kittens weigh less than 2.8 pounds? So I'm going to go to 2.8, and I want to find the area that's below it. So I know that the very first little section is 0.15, and the other is 2.35. So when I add those together, I get 2.5. So 2.5% weigh less than 2.8 pounds. The next question, it says, what value corresponds to the 97.5 percentile? All right, so percentile means at or below. So I need to find the value that would be at 97.5 or below. So I'm going to add up all of the percents until I get to 97.5. So 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5 again gives me 97.5%. So that is happening two standard deviations above the mean, which is at 4.4 pounds. All right, go Seahawks.